The last video for chapter 3. We're still in section 3.3. We're going to talk about quartiles. Quartiles, if you understand percentiles, are no different. They're just special percentiles. And when you think of the word quartiles, you should think of the word, say, quarters. Because what quartiles do is they separate the data into 4 quarters. That makes sense. And because quarters are 25 cents, it makes sense that quartiles are 25% of the data values between each of them. So key things to note, if you were to find the 20th percentile, that's Q1, and the 75th percentile is Q3. A quarter is 25 cents, 3 quarters is 75 cents, so it makes sense. And then a great one is that Q2 is the median because it is the 50th percentile. It's the value that's right in the middle. So all of these quartiles are simply percentiles, and the special one is, of course, the median. So what we can do with quartiles is we can make a box plot. And a box plot is literally a boxy looking representation of data. And we're going to do one, and it requires what's called the 5-number summary. So there's 5 numbers that make up a box plot. So we're going to use our data from the home buying, the home prices. So please make sure you have that data available. And we're going to get our 5 numbers. So we need the minimum and maximum values in the data set. So if you take a look at your data, you should see that the minimum value is 128,000. Notice the maximum, 525,000. These homes obviously not in LA. And now we find the median, so that's that middle value. So because there are 38 values, we can do 38 divided by 2. That's going to give us 19. But notice that's going to give us 19, but that's not the middle value because there's an even number of values. So if you remember from the earlier here, well, if you remember from doing the median, so we're going to take the 19th, we're going to add the 20th, and we're going to divide by 2. These things aren't really equal, so I'll just do that. And that will give us, I have it here, 176 plus 177 divided by 2. So you can see that that's going to be 176.5. So Q2, the median, is 176,500. So now we've already got 3 of the numbers in our 5-number summary. Then we need our Q1, which is the 25th percentile. So we need our locator value. So we're doing a couple more examples of the second thing that we did with percentiles. We take 25, we divide it by 100. So this is just literally 0.25. And we multiply it by how many data values there are to see what data value we need to find within the data set. So when we do this, we get 9.5. Remember from the instructions, it tells us to round up. So anytime you have a decimal, you have to round up. So we want the 10th value. And so then we go into our data set and we find the 10th value. So we go along and we see what the 10th value is, and it's going to be 163,000. Now what would be best is if you could pause and see if you could get Q3. That would really tell you that you understand this idea of percentiles. So to find Q3, we will first do our locator, 75 divided by 100. We multiply that by 38. We're really just trying to find where are 75% of the values, like on what data value does that sit? So you'll have 28.5 when you do that. So make sure you can get that. We need to round that up as it is a decimal to the 29th. And that means that Q3 is the 29th value. So you go through, find the 29th, you can work backwards if you wanted to, and you would get 210,000. So here's our 5-number summary. The way we would list it is we'd start with the smallest, so that's 128,000. We'd then go to the Q1, so it's min Q1, Q2, Q3, and then max. That will be the order. So Q1 is 163,000. Q2, our median, 176,500. Q3, 210,000. And our maximum, 525,000. So those are the values in the 5-number summary. Now we're going to use them to make a box plot. So here's the directions for a box plot. It is pretty straightforward once you see an example of it. So it says place the 5-number summary for a data set on a number line, draw a straight line connecting them. So what I'll do is, I need to see what my numbers are here. Okay, so 128,000 sits somewhere here. So notice that these are in 50,000 increments. So this would be like 150,000. So 128 will be somewhere here. 163,000 will be somewhere here. So see if you can put the other values on to your notes. You can pause if you need to. 176,000, then we have a 210,000, and we have a 525,000, which is way out here. Now I know these home prices are not from LA because my house was 472,000, which is over here somewhere, and my house is not nearly as nice as many of the houses around here. So remember that for the video quiz. So now that we've put our dots, what we really should do is we can draw a line connecting them, but really we should go min to Q1 and then Q3 all the way out to the max. That's really where you want to have your lines. And typically you'll see a lot of box plots with a line at the min and the max. And then we'll draw a line at Q1, Q2, Q3. So notice we have these kind of straight lines on all of them, some better than others. And once I do that, I then just connect them at the top and at the bottom. And so this is my box plot. Now you can write this down or not, because this is your box plot, so you have everything. But the thing to understand about box plots is that every time you have your Q, you have 25% of the data. So what we're being told is that 25% of the data sits here, 25% of the data sits in this box, 25% of the data sits in this box, and then 25% of the data is all the way from here to here. So it actually gives you a little bit of an idea about the shape of the data, because you can see that the majority of the data for this place, which must be like Indiana or something, sits way to the left, and that there's only 25% of the data sitting to the right of Q3, which is always true, but you can see it's a very widespread, like range, I guess. Because of that, you should understand that you have a lot of data sitting over on this side and less data sitting over this side. So if you were to think about it in terms of if you were to graph this data, you should notice that it would be skewed. And do you know which way it would be skewed? Skewed to the right. Yeah. So now let's do one last example and then we're done with chapter 3. Here are 2 box plots. They are shown for the typical length vacation for California residents who work in the government in some capacity and for those who work in a private company. So basically they looked at a bunch of data, said how many vacation days do you have, say, per year, or length of a typical vacation. So how long do you get to take as a vacation? And then they made box plots for that. So the idea here is to think about, would you rather be a governmental employee or would you rather be a corporate employee based on the length of a typical vacation, understanding what you know about quartiles. We want to just think about center or spread anything else that you think could support your idea. So it would be a good idea to pause this and then come back to it and see what I have to say. So different students feel different ways when they answer this question, and it is essentially opinion because it says, where would you rather work? But you do have to support that. So when students look at this, they often notice that, hey, there's some aspect of governmental employees that have a maximum there of 14 days of vacation. But you want to understand that 25% of the governmental employees have between, say, 9 and 14 days of vacation. I mean, that's pretty good when you think about the fact that the corporate employees don't have any. However, you want to think about as well that 25% of the governmental employees have between 0 and 1 days of vacation, which is almost nothing. So it's kind of a higher risk there. You can see that 100% of the corporate employees have between 2 and 8 days. So essentially you're guaranteed some aspect of vacation being a corporate employee. And this tells us right here that the median amount of time, length of vacation for the corporate employees is 6 days, whereas the median amount of vacation days for government looks to be 4. And remember that median tells you that 50% of the data values lie above and 50% lie below. So you may say, I'm guaranteed more by being a corporate employee than a governmental employee, unless you really want to roll the dice and just hope that you're the person or whatever that gets 2 weeks of vacation. So you can say whatever you want, just so that you have something here. I will tell you what I have. Unless you're welcome to write your own, that's no problem. So I would say I would prefer to be a corporate employee because I'm guaranteed at least a 2-day vacation. I mean, that's not a lot, let's be honest, but vacation. And a basically 50% chance of having, I'm having a hard time, having between 4 and 7 day, between a 4 and 7 day vacation. So many things you could say there, using center, using the idea of spread, the variation with the data. But it's good to be able to understand box plots enough to say a little bit about the data by looking at them. That's chapter 3.